So, good morning, good evening, and good afternoon. As technical officer of this European Space Agency project, I have the honor to welcome you to this final presentation webinar that is hosted in the ESA ESRIN establishment in Italy. We are today delighted to release the WorldCover 2021 map and its product user manual. A bit of history, very fast. In 2017, we invited the WorldCover conference with 400 participants when the ESA Sentinel-2 and Sentinel-1 constellation were completed. In 2018, we opened an invitation to tender where we selected this consortium to perform the activity. And in 2019, we had the kickoff. Last year, in 2021, we had the final presentation for the WorldCover 2020. And today, we are presenting the final product for 2021. I want to record and remember that the 4 cardinal requirements of this project have been met: 10-meter resolution, 10 classes plus mangrove classes, a fast delivery, 10 months from the last data take, and an accuracy reached at 77% overall accuracy. You will hear now the full description of the algorithm and of the validation. I give the room to Ruben, which is the project manager on Vito side.
Thank you, Olivier, for this nice introduction. And also, hi everyone from my side. I'm indeed Ruben van der Kerkhoven from Vito Remote Sensing in Belgium. And it's my honor to host you also on this webinar today. In fact, it's the 3rd webinar we're having on this project. The first one was after the first year of the project. The second one last year when we released the first WorldCover 2020 product. And actually today we release indeed WorldCover 2021. Most likely this will be the last webinar because actually WorldCover is ending. We started 3 years ago, like Olivier mentioned already. But now we conclude this project also with the release of WorldCover 2021. WorldCover has been a fascinating journey together with our partners, Brockman Consult, Gamma Remote Sensing, ESA, and Wageningen University. And together we started on this project, and today we're happy to release to you also WorldCover 2021 after the release of WorldCover 2020 last year. So today we have on the agenda first the status of the project. I will tell you a bit more about that. Then it will be followed by some more technical details on the algorithm improvements and the data products that will be presented by my colleague Daniele Zanaga, followed by the independent validation results, which will be presented by Nandika Tsenbaza from Wageningen University. And then I will present again how you can access this new global land cover product. At the end, we have time foreseen for an interactive discussion. So please, if you have any questions during the webinar, you can put them in the Q&A section. And Miroslava Lesiv from ESA will moderate this discussion section at the end. So like I said, we didn't do this alone. In fact, WorldCover was a team effort. And today we have here in the panel Miroslava Lesiv from ESA, Daniela Zanaga from Vito, Nandika Tsembaza from Wageningen, and as well as Oliver Cartes from Gamma. So at the end, we're all, as well as myself and Olivier Arino from ESA. So at the end, during the interactive discussion, we're available to address any questions. So last year, we presented this beauty. This is the WorldCover 2020 map. The first global land cover map at 10-meter resolution based on Sentinel-1 and Sentinel-2 data. In fact, it has been made based on Sentinel-1 and Sentinel-2 data and comes with 11 classes. Like Olivier mentioned already, we had the cardinal requirements to deliver 10 classes, but in the end, also based on user request, we also added an 11th class called mangroves. And we saw also that because we saw there was a huge demand from the community. There was this product, it has been picked up quite nicely by the community. We see a lot of user feedback via different channels on Twitter, LinkedIn, and other social media, as well as via our website. And the users seem to like the product, especially the fine detail. Actually, WorldCover is the only land cover product which really has a minimum mapping unit of 10-meter resolution. So we're quite pleased with how it has been picked up the last year. However, WorldCover, and also we announced it also last year, there's room for improvement. Yeah, in WorldCover 2020, it had some limitations. We had, like in the top left, some crop commission over wetlands. We had some artifacts, block artifacts in urban areas. Sometimes some areas were more classified as bare instead of the built-up class. On the bottom right, you see an artifact in Mongolia. On the bottom, the center bottom, you see some water commission over glaciers, and on the bottom left, you see some crop omission. So we had some limitations, so there was room for improvement, despite the fact that WorldCover, that most users seem to like the product. So because of that, the agency actually they requested to the consortium to develop also WorldCover 2021, but do that also with an improved retrieval algorithm. This is besides the other cardinal requirements of WorldCover, indeed producing and validating and delivering a 10-meter land cover map, do this as fast as possible, minimum of 10 land cover classes, and with the help of several end users. So today we are quite happy to release to you this new beauty. So this is WorldCover 2021. And in fact, if you would go to our viewer, which here you find a direct link, but you can also get there through the WorldCover website. Actually, you can already start exploring the map. We will later on in this presentation go in a bit more detail and show you some comparisons with the previous map. What is WorldCover 2021? We call it WorldCover 2021 version 2. It's in fact a new global land cover map at 10-meter resolution for 2021. It's based on Sentinel-1 and Sentinel-2 data from 2021 only, January to December. And like I said, it uses an updated retrieval algorithm compared to WorldCover 2020 version 1. Therefore, it's independent from the 2020 map. Actually, WorldCover 2021, it's an improved, up-to-date, and more accurate representation of the actual land cover compared to WorldCover 2020. What's important is actually what is WorldCover not. WorldCover 2021, it's not consistent with WorldCover 2020. Like we said, it uses a different algorithm version. So in fact, changes between WorldCover 2020 and WorldCover 2021 contain changes both due to differences in the algorithm as well as actual changes in land cover. In fact, these changes due to the difference in the algorithms are the majority of the changes which you will observe in the maps. Therefore, we have one strong recommendation. Users should not use the two maps for change detection, but rather use it as an improved base map in their application. With the last one, I mean use WorldCover 2021 as an improved base map in your application. This is quite important. Let me show you an example of how that looks like. This is, for instance, WorldCover 2020, so the previous version of the map, in an area in northern Uganda. What you see there, we have a nice lakes, we see some shrubs, some trees, some grass, some wetlands. You see the legend on the top left. However, what we noted is actually that in this area we have lots of crop omission. So we miss a lot of croplands. Also, we miss some wetlands, and we miss also some tree cover. Actually, we got some user feedback on this area. This is how WorldCover 21 looks like then. Let me go back. I'm not sure if you can see the image. Yes, so this is WorldCover 2021. Let me go back to WorldCover 2020. You see there's really some huge changes. So especially on the cropland class, we have now really big areas where we now introduce croplands, while before we mapped it mostly as shrubs or as grasslands. We also have much more wetlands around the area which you see here on the bottom, the lake, the dam lake, and the bottom. You see much more wetlands on the tributaries to that lake, as well as we have also more tree cover. And actually, this is correct. So in this area, we see that the changes between the two maps, they're mostly due to algorithm changes. Let me show you another example. This is an example over Egypt. These are actually the Toshka lakes in Egypt. And on the top row, actually, you see some Sentinel-2 false color composites in 2020 and 2021. On the right, it's 2021. So you see actually that in 2021, the water level of those lakes, it's much higher. We had much more water. And besides that, you also see that if you would look a bit more closely, that there's much more agriculture, so-called pivot irrigation in the map. So on the bottom, you see then the resulting WorldCover maps for 2020 on the left and 2021 on the right. Actually, here, the changes that we see are actual land cover changes, at least most of them. So WorldCover, like I said, it's comprised both actual land cover changes as changes due to the algorithms. So this was my introduction. I will give now the floor to my colleague Daniele Zanaga, who will tell you a little bit more about the actual algorithm improvements that were done in WorldCover 2021.
Yeah, hello everybody. So I'm Daniele Zanaga, the main developer responsible for the algorithm development of the WorldCover project. I'm gonna start presentation summarizing a bit the workflow. This is the same workflow that we used for last year map for WorldCover 2020. We start from the data sets. So we have Sentinel-2 L2A, we have Sentinel-1 GRD products, and then a set of auxiliary layers, which includes the Copernicus DM and other auxiliary layers, and as well as the training data corpus, which I will describe in more detail later on. We have a first phase where we filter the Sentinel-2 products. So we filter based on cloud cover, and then we process. And then we have also pre-processing of Sentinel-1. We go from GRD to gamma naught correction. And after that, we process the data, we extract features, and with the features, we extract training locations for which we have labels provided by ESA and also extracted internally. But again, I will talk about that a bit later. We train our classifiers, and after the training, we run the global prediction of the map. And finally, we have a third phase where we have a combination of the different models that were trained to generate the final map. This is our simplified workflow. So a bit about the data sets. So we process Sentinel-1 data. We process more than 230,000 GRD products. So approximately for 1 year of data, it's 0.8 petabytes. And then we process as well approximately 18,000 Sentinel-2 tiles, more than 2 million L2A products that are collected in 1 year. That's more than 1.2 petabytes of data. So processing of a 1 year WorldCover map requires that we go through approximately 2 petabytes of data. And this is carried out processing time approximately in 3 weeks. This is a schematization on how we actually process the data. So we go from the data loading. Then for Sentinel-2, we have cloud screening. So we remove clouds. For Sentinel-1, we also have a cleaning process, which is based on a multi-temporal speckled filter. As you may know, Sentinel-1 is affected by speckle noise. Then we have data compositing. So we take the cleaned data which normally is acquired at different timestamp in the different points of the globe, and we homogenize that. So we compute a 10-day median composite based on a 20-day moving window. And out of that, we get a cleaned time series. We interpolate for missing value. It might occur that we might have longer periods of clouds or cloud cover, so we might still have some missing value. So we interpolate that. And with the cleaned time series, we extract temporal statistics. So the 10th percentile, the median value, the 90th percentile, and the interquartile range for these bands, as well as for vegetation indices that are computed from both Sentinel-2 and Sentinel-1, like, for example, the NDVI or NDMI. And these compose our set of features. We have in total approximately 115 features. And for a detailed list of the features that are used, I would refer you to the product user manual. So let me go on. The objectives that we set out for our version 2 of the WorldCover product were basically to correct the commission and omission errors that we observed in the previous map and that were reported by the users. So we had several months of user feedback and also ourselves checking the product. And we observed some of the main issues that were contributing to lack of accuracy in our product. So certain areas where we had cropland omission or commission. We had issues in certain areas in drylands, confusion a bit, like specifically in East Africa, for example, between shrubs and trees. And as well as tree commission, so excessive tree prediction in certain areas, northern hemispheres, or also heterogeneous areas. So we wanted to improve these issues and produce a better map. So we designed an improvement of our methodology, which started as a first thing as an improvement of the training data. So we realized, analyzing the map and analyzing our data set, our training data set, that most of the issues were due to noise present in the training data set. So the machine learning algorithm that we use, which is CatBoost, and we use it as a pixel classifier for our product, can be, as any machine learning algorithm, in fact, sensitive about noise in the training data. And this noise can cause confusion of the classification algorithm. In order to fix this, we remove outliers, we rebuilt actually our training data set. And on top of that, our partner, ESA, did an enormous effort in the short time that we had to add another 30,000 additional locations. So the regional specialists for our partners collected additional training locations from the affected areas to improve our algorithm. This was one part of our improvements. The second part is the pipeline. So last year we had a big issue that we couldn't refine our trained algorithm live because it would take a lot of effort. So this year instead we designed an iterative and incremental update pipeline. And what do I mean with this? I mean that what we were doing was optimization of a first algorithm, classification on the first prototype or selected parts, and then we had a pipeline to actually add additional training data in the locations that were observed to still be subject to issues, and again repeat this process. And this is what allowed us to increment the quality of the product, because we were able to go into this loop several times to obtain what the final product that you are gonna able to browse. So this cleaning of the training data and the cleanization of the pipeline led to a more robust and accurate classifier, which resulted in a better product. So a couple of words on the training data. So our training data, the base corpus comes from ESA that was produced starting a few years ago from, I think, 2015. We started collecting this training data set, which is huge. It had more than 130,000 locations collected in a grid of 10 by 10 pixels, so 100 by 100 meter. On top of that, we also used additional sampling strategies. So we used OpenStreetMap and the Global Surface Water Explorer layers to opportunistically sample automatically in a semi-automatic way additional training locations to integrate for the lack of training data for specifically urban and water classes in the original ESA training dataset. And additionally, we also collected in this way training data for mangroves. And based on users' feedback that we received, we added an additional 10,000 locations. So in 2020, we had a total of 270,000 training locations, which became this year, after the efforts that were done by our partner, a total of 320,000 training locations. So this already explains the improvements that we had. After the collection of the training data, we proceed to deploy a Spark cluster on Kubernetes on AWS, and we run the global processing. So we have we do processing in blocks of 10 by 10 kilometers, and we have approximately 1.4 million blocks. And that is the global map, which consists in the end of approximately 80 terabytes of data that we produce as an output of the processing, and that is used for the map generation. Here are some comparisons, examples between last year map and this year. You see here an area in Sahel where we had a bit of omission of cropland. So we collected additional training data here. It's quite some large area. Of course, this is a very challenging area because it's dry land and it's very difficult to classify different types of vegetation like cropland. Here is yet another area in South Sudan. You see we have kind of a lot of gray spots, which gray is bare, by the way, just for those that are not familiar with our legend. Pink is cropland. And you see here we were basically missing out a lot of villages or settlements, which are very difficult to map in Africa because of the kind of settlements. They are not the typical urban settlements that we have in the northern, that you can find in more developed countries. But here you can see in the red spots, these are all small settlements. This is a large area in South Sudan that were missing last year. And it's not only here, it's in general. We improved urban quite significantly. This was requested also by users. This is another example where we improved both urban and cropland. You see last year map, we had this kind of artifact where our classifier was a bit confused between bare and urban, because you can imagine they have spectrally a similar signal. And in this year map, this is corrected. And you can see also the pink patch on the right, it's all cropland that we now correctly classify. So this is another area. Now, water improvement. This is in US, eastern part of US, and this is clear water that we have here. This is the Sentinel-1 composite. I will have a couple of words on the composites later on. This is clearly water, also from Sentinel-1. Last year, due to noise in the training data, this was not really well classified. And you see this year, training data cleaning and optimization led to a better classification of this water. Also, water in the Amazon rivers last year were not properly classified, also due to noise as well. And this year, we have much better rivers. This is all regions like the Amazon forest and Central Africa rainforest. We have much better water. Again, better snow classification on glaciers. We have quite a common artifact, some snow commission over glaciers, because where you have shadows or on ice or snow, this might look as water. So this year we have already an improved classification of snow. We still have a bit of commission of water on glaciers, but it's much improved. This is an example of wetland. This is last year. This is this year. There's an improvement. This is another example of wetland. This is Central Australia. Last year mapping was not so good. There's a bit of, it's not very well mapped. So we added training data optimized for this area, and we are now able to map it much better. Another type of issues were also artifacts. Here you see some blocky artifacts due to the block processing and some bugs in the features extraction steps. In this case, due to the low number of observations, and these kind of artifacts were also fixed. Here you see the new map this year. It's correctly classified this area as trees. The new product, same way as last year, is delivered as a set of 2,651 tiles. They are cloud optimized geotips. They are in total 124 gigabytes in last done projection. So as a part of, we want to make here an announcement. As a part of WorldCover, we also produced global yearly median composites for Sentinel-2, RGB and infrared band, as well as, this is the infrared false color composite, as well as for Sentinel-1 gamma naught. This is 1 year of data gets, we compute the median value. So these are cloud-free continuous composites. And we are gonna release these composites as open data for 2020 and 2021. We had some feedback by several users expressing their interest in these data sets. So we are confident that this will be an opportunity for many users, because we're presenting this 10-meter spatially coherent and temporally coherent data set. So you would have then the WorldCover map, but as well as the features. So the global cloud-free Sentinel-2 and Sentinel-1 composites, which can be used for several applications, as well as machine learning application, because now you are able to build training data sets and run global prediction on these data sets. They will also be released in 1x1 degree types. There will be 10 terabytes per year, cloud optimized geotips. We will serve also a stake API, which users can use to access the data sets, and they will be published as public data sets on the AWS Open Data Registry. We target the release in approximately a month. So maybe just final word on the, as you might know, Sentinel-1B had recently a failure. So ESA had to reschedule the acquisition pattern for Sentinel-1. This means that because our product is based on both Sentinel-2 and Sentinel-1, part of the globe will actually lack Sentinel-1 cover, since only Sentinel-1A is now orbiting the globe until the launch of Sentinel-1C. This means that probably there will be a lack of consistency between the current year product and eventually next year product, in case we're going to produce it. And we also expect a decrease in accuracy due to the lack of Sentinel-1. But this has to be investigated further. I'm going to now leave the floor to Nandita for validation.
Thank you, Daniel. All right, so my name is Nandita Timpasa. I work at the Wageningen University. Wageningen University has been responsible for the independent validation of this WorldCover product. So to make this happen, we have made use of an independent validation dataset, which we have collected a couple of years ago as part of Copernicus Global Land Truth activities. So this dataset is, we have more than 21,000 locations, primary sampling locations, and with each continent having at least 3,000 primary sampling locations. So this dataset is a multi-purpose validation dataset. That means that we can use this dataset to validate maps from 10 to 100 meter resolution maps. But yeah, you can find more details about this dataset in the product validation report. This dataset was collected on GeoWiki, which has created a separate data collection interface for us by ESA. So within this interface, we were able to make use of available and different layers, and also Sentinel-2 time series thumbnails and other possibilities to collect reference data, as you can see on the right, where we have 10 by 10 meter blocks in which each Sentinel pixel size pixels are labeled in terms of land cover. So this dataset was collected with help of 30 regional experts and that have contributed. You can see their area that they have contributed and their affiliation and name in here. And these experts are independent from the training data experts, which Daniela mentioned earlier. This dataset was originally have information on land cover for 2015, but we have been putting in quite a bit of effort to update this dataset to 2021 using random and targeted revisions. Targeted revisions which are focused on possible land cover change areas. All right, so with this dataset, with the updated dataset, we were able to assess the accuracy of this new WorldCover product. So based on our 2.1 million secondary sampling units, we have estimated the accuracy to be 76.7% accuracy. And yeah, we see also quite high accuracy in classes like tree cover and snow ice, water, cropland, bare and sparse classes. They have quite high accuracy, but then you also have comparatively lower accuracy for shrubs and wetlands as well. And overall, at the global scale, we see some overestimation of trees and some underestimation of moss and lichen classes. So these are generically observed. And we can also assess the accuracy of this product per continent. For all continents, we have seen an accuracy of above 72% accuracy. And from the continents, Asia had the highest accuracy, as 82% accuracy, followed by South America, Europe, and Africa. Yeah, so like I said earlier, for all continents, tree cover is quite high in terms of accuracy, but there's a bit of a variation between the continents as well. So we saw also an overestimation of tree cover for continents other than Africa. In Africa, the overestimation and underestimation balances quite well. Similarly, bare and sparse vegetation class, which has a quite high occurrence in Africa and Asia, and this area had higher accuracy for this class. But for continents such as Europe, which has a very low occurrence of this class, the accuracy was a bit limited. But for other classes, the class accuracies were more or less similar for different continents. Yeah, I think that was it from my side.
Yeah, thank you, Nandika. Thank you, Daniele, for providing us more details on the algorithm and also on the validation figures of WorldCover 2021. I will now give a bit more details on how you can access the product. Actually, I gave already in the beginning the link to the viewer, and those that are familiar with WorldCover 2020 will probably have already found their way to the website, where currently already all the new product details already mentioned. So for those who are not so familiar with WorldCover, actually we have a viewer which you can find at this web link or through ESA-worldcover.org. So compared to last year, we now added also WorldCover 2021 version 2. You see there's a blue disclaimer saying that this product should not really be used for change detection. Besides the maps, we also provide there the option to view the composite, Sentinel-1 and Sentinel-2. So this is, for instance, the Sentinel-2 RGB composite for 2021. This is the false color composite, and this is the Sentinel-1 composite. So you can do quite a lot with this viewer. Actually, you can view it, but you can also calculate statistics for your certain countries. You can export the maps to, for instance, PNGs, which you can share via social media. But you can also download the maps even. And this year, actually, we also introduced a new feature. So the team worked also on adding a compare function. So on the left, you see a panel which you can click compare, and actually on the bottom, you can then select, for instance, which layer you want to compare, the two layers that you want to compare. For instance, the Sentinel-2 false color composite of 2021, here with the WorldCover version of 2021, and then with the slide, and basically you can go over the product and see actually how the land cover corresponds to the underlying Sentinel-2 and Sentinel-1 data. If you want to download the product, we advise that if you have a certain region of interest, example, a certain country or a certain region, you can use the WorldCover viewer, because there you have the graphical user interface. You can also do this programmatically. If you want to download the full product, we recommend to use Amazon Web Services, because that will go the fastest. Or you can also use the product on Zenodo. Actually, all instructions are available at the website, ESA-worldcover.org/data access. And actually, it also links to some viewers and download options also provided by ESA. So, like Daniele mentioned already, with the Sentinel-1 and Sentinel-2 composites, there will come some stack API. So, but actually already for the WorldCover product currently, there's already a stack endpoint available with the collection ID. So those that are familiar with stack catalogs can basically use that also to query and visualize the products. At the moment, we are working on some notebooks, so also on how to use these the stack collections, and basically we will soon publish this also on our website. So keep an eye on our website for some notebooks. So that will come in the next weeks. If you want to further options, we have the data is ingested on Google Earth Engine. So normally it was already the version 1 2020 dataset was already there in the catalog. Normally the version 2 should be there also today. So please have a look if you're used to Google Earth Engine, and normally the data should be there. We provide also WMS, WTMS services. So if you want to use the layer just as a background in your GS project, you can use these. The data is already also in the on the Sentinel Hub and the other Synergite services, such as a Eurodata Cube, as well as on the OpenEO platform. However, all instructions, if you want to know where you can find the data, it's provided on the ESAWorldCover.org data access. Just a small screenshot here. This is, for instance, the EO browser by Synergite, and you see also the WorldCover version 2. It's also there already available. And then Google Earth Engine, like I mentioned, it's provided in the catalog, as well as there's also a dedicated app to compare the WorldCover 2021 also with Sentinel composites. So if you're more familiar in playing in Google Earth Engine, you can also use that app. Finally, the product is free and open. So the licensing is CC by 4. So please, you can use the product openly and freely. However, you should refer to it. Actually, we are currently working on a reference publication, which we hope to submit somewhere in the next month. In the meantime, you can already also refer to the dataset in TOI, which you find here, which is also provided on the ESA World. More instructions you find also more on the ESA WorldCover site. So the product user manual and product validation report as well, you find also on our website. So have a look there. So with this, I want to conclude my presentation, and actually all the presentations. We have time now for an interactive discussion, so we're more or less on time. We still have about 15 minutes. So Miroslava Lesev from EASA, she normally kept an eye, Miroslava kept an eye on the questions that came in during the presentation. So Miroslava, maybe can you mention a bit about the most relevant questions that people
Yes, thank you very much to all the participants, and also thank you very much for the questions. So we received a couple of them, and they are quite good. I think there are 3 questions that are a bit related, and I want to ask them to you, Ruben. I want you to answer them basically. The first question is from Frederick, who is asking: will there be a WorldCover 2020 produced with the same algorithm as WorldCover 2021?
Yeah, that's a good question. And actually, it's something that we're at the moment also discussing. We're also trying to secure funding maybe for that. At the moment, it's not foreseen. It's not planned in the project. So we might do that, but I suggest you keep an eye on our website, and we will announce it when it will be there. So currently not yet, but we're thinking of it because indeed we see a lot of demand from users. So it might come in the near future, but first we need to find some funding to do that.
Do the team has funding to produce WorldCover 2020, 23, 24, and etc.?
Well, actually, we are at the end of the project normally. So WorldCover, it's in fact a demonstration project commissioned by the European Space Agency, which basically has the main goal of it was to develop a new land cover map based on Sentinel-1 and Sentinel-2. So all the science has been done here in this project. I think the next steps normally it would be that it's picked up by some operation service, being it either Copernicus or something else. So we don't have the funding at the moment. Similar as for let's say the production of the 2020 map with version 2, we're looking to secure some funding for that. So again, keep an eye on the website. I don't know, maybe Olivier, if you want to also comment on that.
No, we did in ESA our development and demonstration activity. This is our mandate. We don't have any mandate for an operational production, which is meant by the question here. So basically, if you are from the European member state, you may request your delegation to particularly fund some particularity of the project, but there is no plan yet on the subject.
Thank you, Olivier.
Thank you. And let's continue. So, and a related question. Do you consider that the methodology is now robust enough that change detection is possible with a future version?
I think maybe that's a question that Daniele can address.
Yes. Yeah, this is something we are still investigating because the world is, we learned that the world is quite big and it takes a lot of time to check, perform quality check of the product before release. So ideally, we would indeed like to produce 2020 and produce land cover change product. We think that we are getting there. The algorithm is more robust, but it's also true that the globe is not really static, and year after year, you don't only have land cover changes, but you also have changes in meteorological condition. You might have drier years or wetter years, and the vegetation will look different. Training data is affected. Classification is therefore more challenging. So that's work in progress. We need to investigate that, and but I think we will get there. Not sure about the timeline, but if there will be 2023 product, it will probably come with a change product as well. That's where we want to go.
Thank you. And maybe just a very quick question to you, Daniele, on OpenStreetMaps. How exactly it was using the classification, but very quickly,
Yes.
if you can reply.
Yes, of course. So the first thing, we use OpenStreetMap for opportunistic sampling of training data. So in our original training data set, we were lacking urban training data. So we used OpenStreetMap global layers to sample for locations where to extract training data. And then secondary step, at the end of the classification, with a pixel classifier, it often occurs that in some areas, you might get confusion between bright bare surfaces and building, urban cover. So in this case, we not only use OpenStreetMap, we use a combination of OpenStreetMap, World Settlement Footprint 2019, the global human surface layer, settlement layer, sorry, to 2019 to estimate the likelihood that if we have a pixel that is predicted urban, we use these additional layers to estimate the likelihood that the prediction is correct. And based on certain rules that we implemented, if it's likely that the pixel is urban, so if there is agreement with the other layers, then we keep the prediction. If not, we have rules to estimate what's the possible class, and we consider that as an error of the classifier. And we have been doing work on this to actually implement methodology based on deep learning algorithms to have this likelihood estimation coming from one of our algorithms, but that's still work in progress.
Many thanks, Daniele. And so there is a question about the viewer. I guess this is to you, Ruben. Will the community feedback feature of WorldCover Viewer be available for users to report the issues with the new map?
Yeah, thank you for the question. I think probably I didn't address it during the presentation, but last year we actually implemented the feedback panel. So if you're logged in the viewer, you also see a feedback panel, actually, where you can submit areas which you think there's something wrong with the map. Yeah, you can delineate a polygon where actually you think, okay, for instance, I see here some crop commission, maybe it should be grass. You can delineate a polygon and submit that in the viewer. Actually, we use that feedback quite a lot also for improving our map. So yes, the feature will be still there. And please, yes, continue with providing feedback. Thanks a lot, Elena, for all the feedback there, actually.
And now there is a very technical question about the cloud coverage, and maybe this is to Daniele or Oliver. What is the allowed maximum cloud coverage in a satellite image that is okay to use for forest cover mapping?
Didn't understand.
Sorry, I will read it slowly. What is the allowable maximum cloud coverage in percentages in a satellite image that is okay to use for forest cover mapping?
Yes. So yeah, that's I actually I cannot give a direct answer, but that's in fact why we use also Sentinel-1, right? So in our map generation we have different models, and if we see that the cloud cover is beyond a certain threshold, I think 85%. This is determined empirically based on our map generation iterations. Then we actually switch to a model that doesn't use Sentinel-2, because when there is too much cloud cover yearly, then it often happens that the observations that are not flagged as cloud, they might still have some cloud residual and noise. So we see that the more cloud cover you have, and the more the good signal is affected by noise, and as a consequence, the prediction is done wrong. So our threshold is actually 85%, and after that, we switch to a pure Sentinel-1 model.
Yeah, is there one more burning question, maybe?
I'm sorry, I don't hear you. Is it only my problem on my side?
Okay. You don't hear us?
Hello?
Fabrizio, you don't hear us.
Okay, maybe you can shake your head if you can hear me.
Yeah, we hear you.
Okay, I don't hear you for some reason, but
Okay. Let me check. So people from the chat.
I am wondering if other participants can hear you.
Okay,
If we can
so
get
yeah,
some
other
quick
participants.
feedback.
Okay, so let's see if there are maybe last question, and I think we need to close the webinar.
If there's a last question, maybe you can see.
Yeah, we can select, but she cannot hear us. So
the one about augmentation of training data, did you account for change between 2020 and 2021?
indeed.
Okay, so maybe this is just a problem on my side.
Yeah, I will take.
So there were a few more questions, but maybe just because we do have very little time left, we can focus perhaps on this one. Can the algorithm be applied pre-2020 for 2017 or 2019 land cover classification? So basically, can we apply it for some past classifications going back?
Again, the algorithm, yes, it can be applied. But as I mentioned earlier, vegetation signal spectrally can differ quite some from year to year. It depends on the local meteorological conditions. So this means that what we see is the most effective is that every year that we extract training data for every year. But the workflow can be applied, and in fact we would love to back process previous years, and I think at some point if the interest is enough and we can secure funding, we might do that, so that we go back and process a consistent collection from the beginning of Sentinel-2
constellation in 1918.
Yeah, so in fact, global coverage for Sentinel-2 starts, fully, let's say, from 2018. So yes, there are no plans, and I don't think this will happen very soon. But I mean, the Sentinel constellation is here and will be here for many years. So we can imagine that at some point in the next 5 years, we will reach there.
Thank you, Daniele. And perhaps the last technical question. It's in the augmentation of the training data set, did you account for changes in Lnkaba that happened between 2020 and 2021?
Yes, so we didn't account for that directly, but we had a strategy to remove noise. So you can imagine that on 320,000 locations that we had this year, of course, some of them are affected by change, but they will be a minority, and they will result as noise in the training corpus. So normally our methods to clean that noise should remove those. And when that doesn't work, we add additional training data on top of that until the effect of this noise is suppressed. So outlier detection is a branch on its own, and it's very challenging. So there is a certain limit on what you can remove before you alter your training data. So that's all.
Thank you. And the last question, I think very kind one. Are there any areas of the map you personally find the most interesting and beautiful? I think this is to all the team, if you can share this.
I am a fan of pivot irrigation, so I like those. That's my favorite that you can find in US and in the desert in Africa and.
Pivot irrigation is really nice. I personally, and I think maybe we can close with that. I did my PhD on permafrost mapping, so I'm looking a lot to the north, and yeah, it's fascinating what you have in these regions. So that's I mostly like the north, the lichens and mosses, Svalbard and so on. So it's yeah.
Another area, just to conclude, which I advise users to check out is China, and specifically these huge urbanized areas. It's very impressive, and in the map it's really nice because you see all the cities in red in these huge cropland areas. That's also one, I think, of the most beautiful areas in our map.
Okay. Thank you, Miroslava, for moderating this discussion session, and thanks everyone for also all the questions. I hope you enjoyed the webinar. I hope you will enjoy our new WorldCover 2021 map. So please have a look to it. This webinar was recorded, so it will come online. So you can, for some colleagues who have missed it, you might distribute the link in the near future. So thanks again for attending. Thanks also to the agency for the opportunity to do this work. And please submit any feedback in the viewer or via email. We're always happy to receive that and further improve the map. So thank you. Have a good day. Have a good weekend. And maybe see you next time. Bye-bye.
Bye, everybody.
Bye bye. Ciao.
Bye-bye.